Range cords for electric ranges and ovens often utilize a combination of wire gauges. A common configuration is 6/2 with 8/2. The 6/2 portion typically consists of two number 6 American wire gauge conductors, which are the hot legs, and a neutral conductor that is also number 6 American wire gauge. The 8/2 portion consists of a number 8 American wire gauge equipment grounding conductor and a number 8 American wire gauge neutral conductor. Now, regarding the question of derating the ground and equipment grounding conductor when run in electrical metallic tubing (EMT) or polyvinyl chloride (PVC) conduit, it's essential to understand the requirements outlined in the National Electrical Code (NEC). The NEC provides specific guidelines for conductor ampacity, including derating factors based on the number of current-carrying conductors in a raceway or cable. First, let's clarify the roles of the conductors. The two number 6 American wire gauge conductors are the ungrounded, or hot, conductors that carry the primary current to the range. The number 6 American wire gauge neutral conductor carries the unbalanced current from the 120 volt circuits within the range, such as the oven light or electronic controls. The number 8 American wire gauge equipment grounding conductor provides a path for fault current to return to the source, tripping a breaker or blowing a fuse in the event of a short circuit. It is important to note that the equipment grounding conductor does not normally carry current. Derating factors are applied when the number of current-carrying conductors in a raceway exceeds 3. According to NEC Table 310.15, B3, A, when there are 4 to 6 current-carrying conductors in a raceway, the ampacity of each conductor must be derated to 80% of its allowable ampacity. When there are 7 to 9 current-carrying conductors in a raceway, the ampacity of each conductor must be derated to 70% of its allowable ampacity. However, the NEC also provides exceptions to this rule. Specifically, equipment grounding conductors are not considered current-carrying conductors for the purposes of derating. This is because equipment grounding conductors are intended to carry fault current only, and they do not normally carry current during regular operation. Therefore, the number 8 American wire gauge equipment grounding conductor in the range cord does not need to be derated, regardless of whether it is run in EMT or PVC conduit. Now, for the number 6 American wire gauge neutral conductor, whether or not it needs to be considered a current-carrying conductor for derating purposes depends on the specific application and the characteristics of the load. According to NEC Section 310.15, B5, a neutral conductor is considered a current-carrying conductor when it carries more than 50% of the phase current. This can occur in circuits with significant nonlinear loads, such as those found in some electronic equipment. However, in a typical residential range circuit, the neutral current is usually much less than 50% of the phase current. This is because the primary loads, such as the heating elements, are resistive and balanced, and the 120 volts loads are typically small. Therefore, in most cases, the number 6 American wire gauge neutral conductor in a range circuit would not need to be considered a current-carrying conductor for derating purposes. However, it is always a good idea to verify the actual neutral current under normal operating conditions to ensure that it is within acceptable limits. To summarize, the number 8 American wire gauge equipment grounding conductor in a range cord does not need to be derated when run in EMT or PVC conduit. The number 6 American wire gauge neutral conductor may need to be considered a current-carrying conductor for derating purposes, depending on the specific application and the characteristics of the load. However, in most cases, the neutral current in a typical residential range circuit is low enough that derating is not required. Always consult the NEC and any applicable local codes for specific requirements and to ensure that all electrical work is performed safely and in compliance with regulations. Keep in mind that proper grounding is critical for electrical safety. It helps to protect against electric shock and fire hazards by providing a low impedance path for fault current to return to the source. Always ensure that the equipment grounding conductor is properly sized and connected to the grounding system. Always refer to the most recent edition of the NEC for the most up-to-date information and requirements. Local codes may also have additional requirements that must be followed. It is important to note that this information is for general guidance only and should not be considered a substitute for professional advice from a qualified electrician. If you are not comfortable working with electricity, it is always best to hire a qualified electrician to perform the work. Furthermore, consider the specific ampacity ratings for the conductors. Number 6. American wire gauge copper conductors typically have an ampacity of 55 amps when operating at 60 degrees Celsius, 65 amps when operating at 75 degrees Celsius, and 75 amps when operating at 90 degrees Celsius, according to NEC Table 310.16. Number 8. American wire gauge copper conductors typically have an ampacity of 40 amps when operating at 60 degrees Celsius, 50 amps when operating at 75 degrees Celsius, and 55 amps when operating at 90 degrees Celsius, according to NEC Table 310.16. These ampacity ratings are based on certain assumptions, such as the ambient temperature and the number of conductors in a raceway. If the actual operating conditions differ from these assumptions, the ampacity ratings may need to be adjusted accordingly. For example, if the ambient temperature is higher than 30 degrees Celsius, the ampacity of the conductors must be derated. Similarly, if there are more than 3 current-carrying conductors in a raceway, the ampacity of the conductors must be derated, as discussed earlier. Also, consider the terminal temperature ratings. Electrical equipment, such as circuit breakers and receptacles, are typically marked with a temperature rating, such as 60 degrees Celsius or 75 degrees Celsius. This temperature rating indicates the maximum temperature that the equipment can withstand. When selecting conductors, it is important to choose conductors that are rated for at least the same temperature as the equipment to which they will be connected. For example, if a circuit breaker is rated for 75 degrees Celsius, the conductors connected to the breaker must also be rated for at least 75 degrees Celsius. If the conductors are not rated for at least the same temperature as the equipment, the ampacity of the conductors must be derated. Remember to consult the NEC and any applicable local codes for specific requirements and to ensure that all electrical work is performed safely and in compliance with regulations.